Okay, I'd like to continue with the 4.2a lesson. This graphic is one of the most important ones you can have open when you're doing your homework because this really shows how the different quadrilaterals are related. One of the things that's true about quadrilaterals is that they inherit traits. So just like any good flow chart, wherever there's an arrow connecting, things are going to filter down. So when we put our definitions on here, you will begin to see how the qualities filter down from previous shapes. So quadrilaterals obviously have 4 sides. If we start over here with a trapezoid, we have 1 pair parallel sides. That's the definition. As we move down, we get more specific. We get an isosceles trapezoid that continues to have that 1 pair parallel, and it has equal legs. That's its additional piece of information. Related but not connected is a right trapezoid that's going to have our 1 pair parallel. Its additional information is it's going to have at least one right angle. In this case, it has 2. Now a kite has our 2 pair consecutive equal sides. This is the quadrilateral that kind of stands out because it doesn't have any parallel sides. A more specific kind of kite is a right kite, and it's going to have at least one right angle somewhere in it. Now a parallelogram is going to have 2 pair parallel sides. So if we think about marking those, every figure that is connected below a parallelogram also has 2 pair parallel sides. So a rectangle has 2 pair parallel sides. Plus, it has 4 right angles. A rhombus is going to have 2 pair parallel sides, and it's going to have 4 equal sides because it is below that parallelogram. So it gets the qualities. Just like you inherited a quality from your grandparents, so do parallelograms inherit qualities from the figures above them. So a square gets everything from a parallelogram, everything from a rectangle, and everything from a rhombus to come together with opposite sides parallel, 4 right angles, and 4 equal sides. Now we are going to come back to this quadrilateral hierarchy page, but you can really see how everything filters down, and as you move down the chart, you get more specific. Now there are really 2 kinds of questions I can ask you with these quadrilateral problems. I can ask you to name something as specifically as possible, so get as far down the chart and give it a single name. It's as specific as possible, or I can ask you to give it as many names as possible. So in this case, I have a quadrilateral for A. I have 1 pair parallel lines, which makes it a trapezoid. And these appear to be equal, and so I have an isosceles trapezoid. Filtering down the hierarchy. Obviously, still have a quadrilateral. It appears that these sides are parallel, and I could look at the slope and count it off on a grid, and so this is a parallelogram. And again, if I were using distance formula, I would find that those are all the same, and so I have a rhombus. Because it's not, then I check, do I have right angles? I don't, so I don't go to square, and I stay at rhombus. Here, you start with a quad. My lines are definitely parallel with horizontal and vertical, so I have a parallelogram. I definitely have right angles, so I have a rectangle. And to take that last step down to square, they have to be equal. Like counting boxes, we know they are not. Last one is obviously a quadrilateral. Trapezoid with one pair parallel lines. The sides opposite are not equal, but I have a right angle there. And so this is a right trapezoid. Now, if I go back to my picture for a minute, there's a key breakdown. If you notice, there are no arrows across the diagram. They're all going down. My first column with the parallelogram is everything with two pairs of parallel lines. My middle column is everything with no parallel lines. And my last column is anything that has one pair parallel line. Those are my defining categories that make me choose my path, and then everything filters down below that. Another key kind of question that we can ask is sometimes, always, never questions. And there is a trick. If you move down the chart, okay, then you say sometimes. If you move up the chart, then you say always. Now, why is this? Going down the chart, I'm going from general to specific. So that would sometimes apply. From bottom up, if I'm moving up the chart, I'm moving from more specific to less specific. So if it fit the more specific criteria, it's obviously going to fit the less specific. And if I move across, if I don't follow any arrow path, then it's a never. So a square is a rectangle. And if you look at your hierarchy, square to rectangle, I'm moving from the bottom up, and that makes this an always. Every square you meet is a rectangle. Square is more specific. Is a rectangle a trapezoid? These guys are not connected, and if you look, it's asking me to move across the diagram. That is never. Two pairs of parallel lines is not the same as one pair. Is a quadrilateral a kite? I'm moving from the top down, less specific to more specific, and that is sometimes true. Sometimes a quad is a kite, sometimes it's a parallelogram. That is today's lesson in its two parts, and we will continue with 4.2b tomorrow in class.